Hey all. So we're going to look at a couple more formulas about simplifying and calculating with trigonometry. If you haven't already, please let me know if you're stuck on anything from 7.1 in the form, or setting up a Zoom call, or shooting me an email, anything like that. I'll still be checking emails over Wednesday, Thursday, and Friday of this week while I get things ready for the students in hybrid, but I might just not respond quite as fast as I would normally. But I'll definitely get back to you within 24 hours. So get yourself ready for notes, and let's talk about 7.2. So this is about using addition and subtraction in trigonometry. So the idea here is that if we have the sine of two things added together, now unfortunately we can't just split it apart easily, right? We can't just say, oh, that's the same as sine of A plus the sine of B. But there is a formula, and it says that the sine of A plus B is the same as the sine of A times the cosine of B plus sine of B cosine of A. Now, if it's a subtraction problem here, so if it's the sine of A minus B, then it's exactly the same thing, sine A cosine B, but then just minus sine B cosine A. Now, the cosine formula is a little bit different. It's, instead of sine A cosine B, it's cosine A cosine B. So it's the cosines first together minus the sines first, the sines together. So here it's sine cosine. Here it's cosine, cosine, sine, sine. And again, if it is the subtraction, A minus B, it's the same formula, cosine, cosine, but then the sign is different, so it's plus sine A, sine B. Now, these are complicated formulas. How do you use them? Well, let's look at a couple of problems. So, find the exact value of cosine of 75. Now, 75 isn't one of our special right triangle numbers. However, if you now know addition and subtraction, you can say cosine of 75 is the same as the cosine of 45 plus 30. Now, 45 and 30 are both special right triangles that we know. So the goal for these types of problems is to write this angle. Whoops, sorry, that's the alarm to bake some bread. All right, to write the angle as a sum or a difference of your unit circle angles. So anything 30, 60, 90, 45, anything like that. Then what you want to do is expand using the formula. So here we have cosine of A is 45 and B is 30, and it's plus. So when I expand it, I get cosine of 45 degrees times the cosine of 30 degrees minus sine 45 times sine of 30. So we're just plugging into this formula right here. Now, because we're using our unit circle values, we can plug in the exact values because, as we said here, that's what we're looking for. So using your unit circle, the cosine of 45 degrees is root 2 over 2. The cosine of 30 degrees is root 3 over 2 minus sine of 45, which is root 2 over 2, and sine of 30 is 1 over 2. From there, we're just going to evaluate and simplify. So this becomes root 6 over 4 minus root 2 over 4. They have a common denominator, so we can write this as root 6 minus root 2 over 4. Root 6 and root 2 aren't like terms, so the exact value of cosine of 75 degrees, is root 6 minus root 2 over 4. Now here, find the value of cosine pi over 18, cosine 4 pi over 9. whoop, it left as a word instead of a symbol, that's fine, minus sine pi over 18 times sine of 4 pi over 9. So the main thing that we want to start by seeing is that these are the same, these are the same. So we can think this is our A, this is our B, and then it goes cosine, cosine, minus sine, then A and B, sine. So this is of the form cosine of A plus B, just using our formula. So we can plug that in. We can say, then this is cosine of pi over 18 plus 4 pi over 9. Now we don't know exactly what that is yet, but we can add those terms together, common denominator. So I'm going to multiply this by 2. So then I've got cosine of pi over 18 plus 8 pi over 18, which is cosine of 9 pi over 18, which, after we simplify it, is cosine of pi over 2. Now, pi over 2 is one of our nice unit circle values. If we draw the circle, pi over 2 is at 90 degrees, right up there at the top, which means its cosine value, the x value, is 0. So this whole long string just has a value of 0. As a reminder from previous lessons, sine of negative theta is negative sine theta. Cosine of negative theta is the same as cosine of positive theta. Tangent is like sine, where the negative comes out, like so. You might also be asked to verify things and prove with the subtraction formulas. Here's your tangent addition and subtraction formula. So here it says verify that tangent of x minus pi is equal to the tangent of x. So what I'm going to do there is say that the tangent of x minus pi is the side I want to start with, because that is the unsimplified sign. And I'm going to then use this formula that says that x is A and pi is B. And notice that there's a negative here, so I'm going to make sure I change my signs in the problem. So then I have tangent of x minus tangent of pi all over 1 minus with negative, which becomes plus tangent of x times tangent of pi. Now, the next thing we want to do is find out what the tangent of pi is. So if I'm looking at the unit circle, pi is here, which means that cosine is -1 and sine is 0, so those are both 0. So so that means that tangent of pi, as I said, is 0 over -1, so all 0. So then tangent of x minus tangent of pi just becomes -0. 1 plus tangent x times tangent of pi times 0. And then multiplying by 0, subtracting 0, we end up with tangent of x over 1, which is just equal to tangent x, which, as you'll note here, is the simplified right-hand side of our equation. So we have completed our proof. If you have questions about any of these, please feel free to reach out over the next 3 days, as I will be still working and answering email through until the 16th and that end of the day on Friday.